A bearing is a mechanical component that supports rotating parts. It reduces friction between moving surfaces, allowing smooth and efficient motion in machinery. Bearings are essential in almost every machine you can think of, from small electric motors to large industrial turbines. They ensure parts rotate smoothly and precisely. The main purpose of a bearing is to minimize friction and wear between moving parts. This is very important because it significantly increases the lifespan of the equipment. Bearings also help to carry loads, which can be either radial pushing from the side or axial pushing from the end, depending on how they are designed. There are several different types of bearings, and each one is designed for specific functions and applications. Ball bearings use small rolling balls to keep the inner and outer bearing races separate. They are the most common type you will find. Roller bearings, on the other hand, use cylindrical rollers instead of balls. This allows them to support much heavier loads. Thrust bearings are specially designed to handle axial loads, which means they allow smooth rotation, even under pressure pushing along the shaft's axis. Needle bearings have long, thin rollers that help reduce the overall space needed while still maintaining a high capacity for heavy loads. You can find bearings in many everyday items and complex machines. They are in cars, fans, pumps, motors, and countless other pieces of equipment. The excellent performance of a bearing relies on precise manufacturing and the use of high-quality materials. Bearings are usually made from very tough materials, like hardened steel, ceramic, or special alloys, to ensure they are durable and last a long time. Proper lubrication is super important to reduce friction even further and prevent the bearing from overheating. Without proper lubrication, bearings can quickly wear out, become damaged, or even seize completely during operation, stopping the machine. Bearing failure often happens due to contamination, like dirt, not enough lubrication, or if the parts are not lined up correctly. Cleanliness is extremely important. Tiny dust or dirt particles can scratch the bearing surfaces and cause it to fail prematurely. Bearings work under very high loads and speeds, so it is important to inspect them regularly to make sure they are still in good condition. Analyzing vibrations and noises are common ways to find bearing issues early, before they become big problems. Monitoring temperature can also tell us about a bearing's health. If it is overheating, that is usually a sign of problems. Bearings should always be installed using special precision tools. This prevents them from getting bent or not lining up correctly. If a bearing is installed incorrectly, it can lead to it wearing out much faster and cause the entire machine to fail. Bearing seals are important because they protect the inside parts from dirt and keep the lubrication from leaking out. Some modern bearings even have sensors built right into them. These sensors can check temperature and vibration in real time, like a smart watch for the bearing. Bearing maintenance involves several steps: cleaning, adding new lubrication, careful inspection, and replacing it when it is too worn out. Following a good maintenance schedule makes machines more reliable and reduces the time they have to be stopped for repairs. Always make sure to follow the manufacturer's instructions for what type of lubrication to use and how often to service the bearings. When bearings are taken care of properly, they can continue working reliably for many years of continuous operation. Catching problems early saves a lot of time and prevents expensive machine breakdowns later on. Bearings might be small components, but they play a really big and important role in the world of machinery. Understanding, maintaining, and regularly inspecting bearings ensures that machines operate more smoothly and have a longer working life. Bearings can be grouped by how they move. Some allow rotation, some linear straight-line movement, and some spherical all-around movement. Rotational bearings are the most common type, letting parts spin smoothly around an axis. Linear bearings allow smooth motion in a straight line. You often see these in automated systems, like robotic arms. Spherical bearings permit angular movement, meaning they can tilt and swivel. They are used in heavy-duty joints, where flexibility is needed. Plain bearings, sometimes called bushings, do not have rolling elements. Instead, they rely on sliding contact between surfaces. Magnetic bearings are amazing. They use magnetic fields to levitate the shaft, completely eliminating contact and friction. Fluid bearings use a thin film of liquid or gas to support motion. This also allows movement without any solid contact. Ceramic bearings are light and can handle very high temperatures. They are perfect for places like aerospace and racing where performance is key. Hybrid bearings are a clever mix, combining tough steel races with ceramic balls for even better performance. Choosing the right bearing depends on how much load it needs to carry, how fast it spins, the environment it is in, and how precise it needs to be. If a bearing carries too much load, it can get deformed and fail much sooner than it should. Misalignment means parts are not lined up correctly. This causes uneven stress and wear patterns on the bearing surfaces, making it wear out faster. Bearings can get too hot if the lubrication is not working or if there is too much friction inside. Bearing corrosion often happens when bearings are exposed to moisture or harsh chemicals. Contaminated bearings, especially with dirt, can make strange noises, cause vibrations, or move unevenly. Proper sealing and storing bearings correctly helps protect them from rust and dirt. Bearings should always be handled gently. Even small scratches can cause big problems and major damage. Before installing a bearing, always check that it fits perfectly on the shaft and in its housing. When removing bearings, always use proper tools like bearing pullers or hydraulic presses to do it safely and without damage. Never use too much force or hit bearings directly with a hammer. This can seriously damage the raceway, which is where the balls or rollers move. In many automated systems, bearings often work with very little human supervision, thanks to smart technology. Predictive maintenance uses sensors to help detect problems with bearings before they even cause a failure. Grease and oil lubrication systems can be made automatic to make sure bearings always have the right amount of lubricant for best performance. The right kind of lubricant to use depends on how fast the bearing spins, how much load it carries, and its working environment. Relubrication. Adding more grease or oil should be carefully planned based on how many hours the machine works and the specific conditions. Some bearings are sealed for life, which means they are designed not to need any more lubrication, ever. When a bearing has reached the end of its life, it needs to be replaced right away to prevent other parts of the machine from getting damaged too. Recycling old bearings helps protect our planet by reducing waste and saving valuable resources. Bearings are a true example of precision engineering. Face small components with really big responsibilities. With proper understanding and care, bearings ensure that machines worldwide move efficiently, making our lives better.